Hi guys, today we're going to be learning about another special right triangle. This one is called a 30, 60, 90 special right triangle. And just like we started our previous notes on the 45, 45, 90 special right triangles, we're going to start the 30, 60, 90s by using the Pythagorean theorem and seeing if we can develop a pattern between the legs in this triangle and the hypotenuse. One thing I do want to note in the 30, 60, 90 right triangle that is different than the 45, 45, 90 is these are not isosceles. So the legs have different measures. And that's because the angles that those legs are opposite of have different measures. So the 30-degree angle, the side opposite that would be the shorter leg. And then the larger angle, 60 degrees, would have a longer leg that is opposite. So opposite the 30-degree angle is what we call the short leg, and opposite the 60-degree angle would be the long leg. And then hypotenuse is still the longest side in a triangle, which is opposite your right angle. So where your triangle, however your triangle is positioned, you will find your 30-degree angle, and opposite that is your short leg. So it's not always that the short leg is on the bottom, it's the short leg is opposite the 30-degree angle. All right, so let's jump in on this first right triangle and solve for A. So we're going to do A squared plus 5 squared equals 10 squared. All right, so A squared plus 25 is 100. Subtract 25 from both sides. And we get that A squared is 75. And take the square root of both sides. And again, we're going to use those simplifying radicals for perfect square fractions. We're going to bring that still back here. And this is 25 times 3. This is your perfect square, making A 5 root 3. Okay, so this would be the long leg of this right triangle. So I'm going to write it on the triangle as well. Okay, part B. Again, we're going to do the Pythagorean theorem. So we're going to have 6 root 3 squared plus b squared is 12 squared. So 6 root 3 squared, again, you have to be really careful with this, making sure that you have this in parentheses before you square, because you should be squaring the 6, which is 36, and squaring the square root of 3, which is 3. So 36 times 3 should be 108. So if you're putting this 6 root 3 squared into your calculator and you're not getting 108, you're missing a parentheses. And this is 144. Subtract 108. And b squared is 36. And then let's take the square root of both sides. And we're going to get that b is 6. So in this triangle, b is 6, and that would be the short leg. Okay, what I want you to do right now is to pause the video and go ahead and find the value of c and d using the Pythagorean theorem. And then unpause the video when you're done to check your answers. Okay, let's see how you did finding C and D. Again, the thing I'm most concerned with is you having this entered correctly into your calculators. This 9 root 3 being squared, you should be getting a 243 there. And in 8 root 3 squared, you should be getting a 192. So what was nice about C and D is they both came out to be perfect squares. So what I would like to do now is to complete this table that we have in the middle of our notes and see if we can come up with a pattern between sides. So I talked about the short leg being the side that is opposite the 60-degree angle. So since we have C and D displayed right now, let's look at those two and then we can go back up and fill in for A and B. So for your short leg, In the triangle with the D, short leg is the side opposite the 30, so that would be an 8. Your long leg is the side that is opposite the 60-degree angle. So here's the 60-degree angle. There is the long leg. That's 8 root 3. And then your hypotenuse, the longest leg in a triangle, opposite the 90-degree angle is 16. All right, let's do the same thing with the triangle with the value of C. So your short leg opposite the 30 degrees is a 9. Your long leg opposite the 60 degrees is 9 root 3. And the hypotenuse that we found with the Pythagorean theorem is 18. In the triangle with B, we found the short leg, side opposite 60 degrees, to be a 6. And in the triangle with the missing side labeled A, that was the side opposite the 60-degree angle, we found that to be 5 root 3. So let's take a look and see if we notice any patterns in the relationship between the length of the hypotenuse and the length of the legs. So first concentrate maybe on looking at the short leg and then the hypotenuse. The short leg and the hypotenuse, short leg and the hypotenuse, short leg and the hypotenuse. Did you notice that it's doubled? So 5 times 2 is 10, 6 times 2 is 12, 9 times 2 is 18, and 8 times 2 is 16. So that's one of the two formulas that we're going to use when we're trying to find missing side lengths. The hypotenuse in a 30, 60, 90 right triangle is equal to 2 times the short leg. If we look at the short leg and compare it to the long leg, you'll see that all of our short legs are whole numbers. And if you look at the long leg, all of our long legs have a square root of 3 in front of them. So you're taking the value of your short leg and you're just multiplying it by square root of 3. Short leg multiplied by square root of 3. So our formula to find the long leg is that the long leg equals the short leg times the square root of 3. So our answers won't always be easy to recognize as far as your short leg to your long leg, because if this is not a whole number, then this is going to look a little bit different, but the pattern will always remain the same. Whatever the short leg is, you'll multiply by square root of 3 in order to get the long leg. And whatever your short leg is will be doubled to be the hypotenuse. So what we have in the rest of the notes are just a bunch of examples showing how to find each side if you're given only one side in a triangle. So these rules will apply only to our 30, 60, 90 right triangles. All right, so first thing we're going to need to do is make sure that we're labeling the sides of the triangle correctly so that we know exactly what we have. So in our right triangle here, we've got a hypotenuse. I see this 60-degree angle. That tells me that y is going to be that long leg. And then we're missing a here, but if this is 60, this has got to be 30. So then opposite the 30 would be the short leg. So what I have here is my short leg that's given. And in both of my formulas, I use the short leg to find the long leg, and I use the short leg to find the hypotenuse. So we're going to write these formulas every time we work with the 30, 60, 90 right triangle in order to be able to substitute in information into the right place. So you can see that I'm abbreviating just a little bit here. Hypotenuse equals 2 times short, and long is short times square root of 3. So what we have is, we've got the short leg. So that's 4. So our hypotenuse, which is x, is 2 times our short, which is 4. Our hypotenuse as a measure of 8. Our long leg, which is y, is our short leg, 4, times square root of 3. Nothing else to do there. Y is already alone. Okay, let's move to the back and look at example number 2. So on example number 2, opposite the 30 is your short leg. So x is our short leg. Opposite the 60 is our long leg. So y is the long leg. And then we are given the hypotenuse, which is 20. So our formulas, hypotenuse is 2 times short, and the long leg is the short leg times square root of 3. All right, so in this example, we are given the hypotenuse. So we are given this piece, which means I'm going to have to find the short leg first. If I don't have the short leg, I can't find the long leg. So 2 times short leg is x. Divide both sides by 2. And we get the short leg is 10. That needs to be used over here in order to find the long leg. So the long leg is represented with a y. Short leg is 10 times square root of 3. Nothing else to be done there. Finished. Okay, let's move over to number 3. Number 3, opposite the 30 degrees is my short leg. Opposite 60 is my long leg. And then opposite 90 is my hypotenuse. So I'm going to put my formulas here again. 2 times short, and then long is short times square root of 3. All right, so our short leg now is not a whole number anymore. We're still going to use the same formulas. Our hypotenuse is a y. 2 times our short leg of 4 root 2. We just have to do a little bit of simplification here. You're going to multiply the 2 times the 4 to make it 8 root 2. That's it. It's your hypotenuse. And then our long leg is x. X equals your short leg, 4 root 2, times root 3. So in the hypotenuse, we had 2 times 4 on the outside. Those got multiplied together. For the long leg, you're going to multiply the radicals together. So this is 4 root 6. There's no perfect square factor that goes into 6, so this one is done. Okay, let's move down to example number 4. All right, number 4. Short leg is opposite the 30. I'm going to call that x. Long leg is opposite the 60. I'll call that y. And then my hypotenuse. Our formulas, hypotenuse equals 2 times short and long equals short times square root of 3. So we've got hypotenuse, so we have to start with this first formula. 16 root 3 is 2 times short, which I labeled x because there wasn't a label there on it. And if you divide by 2, the numbers outside here are going to divide to give you 8 root 3. So this is my short leg. I need the short leg to find the long leg. So the long leg I labeled with a y. My short leg turned out to be 8 root 3, and then I'm multiplying that by root 3. So root 3 times root 3 is square root of 9. Square root of 9 is 3, so 8 times 3 gives us a long leg of 24. All right, so then now we're going to move over to example number 5. On example number 5, we're going to bring in that rationalizing, which was some notes that you did for us last week. Okay, so um, this is what's going to happen when we have a long leg that doesn't have a square root of 3 in it. All right, so here goes. We are given a long leg that is a whole number. The short leg we don't know. I'll call it x. And then the hypotenuse we don't know. I'll call it y. Since we are given the long leg, we have to start with the formula that is long equals short times square root of 3. I can't use hypotenuse, which I don't know, equaling 2 times short, which I don't know, because I'd have two different variables. So I have to start with the formula that I know one of the pieces. So in this case, it means I have to start with that long leg of 18. My short leg I labeled x, and then I'm multiplying by square root of 3. So in order for me to get x by itself, I'm going to have to divide by the square root of 3. And this is where the rationalizing comes in. So I end up with 18 over the square root of 3. And we cannot leave that square root of 3 in the denominator. So we're going to multiply by a square root of 3 in the denominator. We have to do the same thing in the numerator. So this gives us 18 root 3 over square root of 9, which is 18 root 3 over 3. And then we can divide that 18 divided by 3 to get 6 root 3. So that is your short leg. Okay, that's right here. Now we can do hypotenuse equals 2 times short, because we know what the short leg is. So the hypotenuse is y. 2 times the short leg we just found was 6 root 3, gives us a hypotenuse of 12 root 3. So you can see now why we did that rationalizing, so that we would be able to manipulate to be able to find the short leg to get the hypotenuse. All right, we're going to do that again in example number 6. So in example number 6, you can see again we've got the long leg that is a whole number. So I need to find the short leg, which I'm going to label as x, and then the hypotenuse, which I'll label as y. So once again, because we have the long leg, we have to start there and find the short leg. And once we do that, we can work with the hypotenuse equals 2 times the short leg. Okay, so the long leg is 21. Short leg I called x times square root of 3. And then we're going to divide. Divide by square root of 3. Divide by square root of 3. Now you've got 21 over square root of 3. Rationalize this. So you multiply by square root of 3. You'll end up with 21 root 3. If you want to do a little shortcut here, this will be square root of 9, which gives you a 3. And then 21 divided by 3 will be 7 root 3 as my short leg. Okay, so that's what we're going to use to find the hypotenuse. All right, so back over here, hypotenuse, which is y, 2 times the short leg we just found by rationalizing of 7 root 3. Multiply those numbers only in front, 14 root 3. Okay, last one, example number 7. We've got hypotenuse given, We're looking for the short leg, which is opposite 30. I'll call it x. And the long leg, which is opposite 60, we'll call it y. So since we are given a hypotenuse, we're going to start with that equation. Hypotenuse equals 2 times short. Okay, so the hypotenuse is 4 root 6. Short leg, we labeled x. Now you're just going to divide by 2. You're going to divide the values outside the radicals. So 4 divided by 2 would be 2 root 6. So this is my short leg. We need that to find the long leg. So long is short times square root of 3. So our long leg was y, short leg 2 root 6 times root 3. So we're going to have to multiply those radicals together. So y equals 2 times the square root of 18. Now 18 has a perfect square factor of 9. So square root 9, square root 2. So 2 times the square root of 9 is 2 times 3 times root 2, meaning that our long leg will be y equals 6 square root of 2. Okay, so that does it for 30, 60, 90 special right triangles. I hope you guys have a great day.